Good day, grade 12 learners. Welcome to today's technical mathematics lesson. My name is Matsidiso Kongwani. This lesson is brought to you by the Gauteng Department of Education with collaboration with Saibono Discovery Center. Our WhatsApp number, grade 12, is 079-578-2908. You are more than welcome to send to that number any clarity seeking question or any alternative solution that you want to share with us in that particular group, grade 12. And then I'm repeating the number. The number is 079-578-2908. Our lesson for today is on paper 1 revision and the exam tips around the topics that are in our paper 1. And then now, remember grade 12, you need enough stationery for your sitting as of tomorrow. You are writing your paper 1. And then all this material must be in a transparent plastic pocket. That means a see-through. Remember, there must be your ID book or ID card, exam timetable, that serves as your admission letter to the exam room, a calculator with a new battery, grade 12. Ensure that you have a spare battery, please. And then a blue pen, and then with an extra pen. Should maybe you have a problem with the first one, you can have an alternative one to use. You must have a pencil for diagrams, and then an eraser to rectify your mistakes made with pencil, and then the ruler, grade 12s. As you can see, no T-Pex grade 12s. In this stationary, no T-Pex, no correctional fluid allowed grade 12s in your exam. And then now, do not try to cram or do the last minute revision or discussion or discuss the exam while waiting to go into the exam room. This may just make you more nervous and confused, grade 12. You have done your work, do not panic, you have prepared well. So be ready now to go into that exam center and reflect whatever you have studied up to this far. And then use a calculator that you have been using when practicing. Please don't take a stranger calculator that you don't even know. When you're looking for a pi, where can you get that pi? Use a calculator that you've been using when you were practicing. The calculator that you are familiar with, grade 12. Do not use any correctional fluid like T-Pex. Rather scratch out a wrong answer. If maybe you made a mistake, take your ruler and draw a line on the wrong answer with a pencil or pen, and then just rewrite the correct one next to that one, okay? If you answer a question twice, grade 12, only the first attempt will be considered. We cannot check between the two which one is correct and so forth. No, that means we will be answering the question for you now. So if we give us two solutions, we will consider only the first one as being the solution. That means if now you have given us a second solution, ensure that you scratch off the first one. And then you must be seated at least an hour before. Our session starts at 9. That means by 8 o'clock, you must be seated, grade 12s. And then you will be given a 10-minute reading time. That means by 10 to 9, you will be given 10 minutes to go through the question paper, not yet writing, but you'll be going through the paper. As you are going through the entire paper, you will be planning within that 10 minutes on how will you answer your questions. Remember, grade 12s, now you can start with the question that you think is more simpler for you. For example, if you feel question 2 is more easier than question 1, you are more than allowed to start with question 2. Please, and then you may start with that particular question. But we advise you in technical mathematics that start with question 1, question 2, and question 3, because those are the easiest questions on your question paper. So if you can ensure that at the beginning of the session, you start with those 3 questions to accumulate enough max grade 12s. And then read the instructions and ensure that you round off all the answers to the correct number of decimal places. In some conditions, they will say to 1 decimal, and then some 2 decimal places. In other cases, they will say leave your answer in surd form. Even if none of that is indicated, grade 12, on your instruction sheet, there will be a bulletin that is telling you that round off all your answers to 2 decimal places unless stated otherwise. Okay, you will be penalized for incorrect rounding off if it is indicated that they need a specific rounding off. And then check whether there are special diagrams provided. Mostly they will be at the back of your question paper, paper 1. If there are diagram sheets, they will be added to your question paper at the back. So as you are given the 10 minutes reading time, paging through your question paper, also check, do you have any diagram sheet at the back of your question paper? It will also be indicated on your instructions if there is such. Use all the 3 hours given to you, grade 12. Please don't rush up and write within 2 minutes and then we are now idling for the remaining 1 hour. No, use all your 3 hours effectively so to write your exam. Try to spend at least 1 minute per mark to be able to finish your paper. Right, and then now let's go through the paper 1 topics once more. We have the main topic, which is algebra, is applicable in other topics. And then this big algebra topic, it's worth 50 plus minus 3 on your paper 1. That is the question 1, 2, 3 that we talked to earlier on, that you need to start with that algebra when you are answering your exam. And then secondly, it will be followed immediately after algebra question 1, 2, 3. It will be functions and graphs. And then, you know, when you talk function, you talk straight line, parabola, hyperbola, exponential together with your circle. In circle, you are having also a semicircle. And then now topic number 3, immediately after your functions, you will be having finance, growth, and decay. We are talking the simple interest, the compound interest, together with the effective and nominal rate. And then lastly, grade 12, we are having differential calculus and your integration. Those will be the last topics at the end of your paper now. Remember, you can start with any topic that you think you are more comfortable with within your paper then. And then now at the back of your question paper, you'll be having an information sheet with all the formulae that you need for paper 1. The one that are starting at the beginning of your information sheet, we start with the paper 1 formulae. And then now I have classified the formulae for you. It will assist you grade 12 if you also do this for yourselves before you start writing. So you look at the back, you'll find this information sheet. The first class here will be on algebra, functions, and graphs. That means you will be applying up to this point when you are talking to algebra and functions. And then followed by finance, growth, and decay. That means where you see the simple interest and the compound interest formula with the effective rate 1. This class is for the finance, growth, and decay. And then followed by differential calculus. With differential calculus, you have only one formula, which is the first principle one. And then now the integration rules, those ones are the ones that are assisting us a lot when we are answering the integration, because we always relate to them in order to be able to apply your integration correctly. So basically grade 12, those are the paper 1 formulae that you need in order to write your paper 1. All right, let's start with the algebra now. As I am going through activities, I will also give you exam tips around each topic. So we are starting with algebra. In algebra now, we look at the quadratic equations. When we talk quadratic equation, we are talking the equation of ax squared plus bx plus c. We are saying it's quadratic because it is to the power 2 there. And then before you can use this formula, sometimes it can be switched up. They can say c plus bx plus ax squared. Grade 12, you need to rearrange this in a correct order. It always starts with an x squared followed by x and then a constant number. That means a number without an x. That is a correct sequence of presenting the quadratic equation. And then now this is the method that we will be following, arranging our formula in order before we can start factorizing or before we can start solving an equation. And then now there are cases whereby some learners, they have a challenge of factorizing directly a quadratic equation. You are more than welcome to use the quadratic formula in all your factorization grade 12s, because basically this was introduced to factorize quadratic equation without vectors, where the x values are irrational. They will give you decimal places. It's where we were emphasizing the usage of the quadratic formula. But this can also assist in case where you have a challenge with the normal factorization of a quadratic equation that is having the rational roots, now x equal to 2, x equal to minus 3, and so forth. And then now, remember now, because you are technical mathematicians, you are also going to involve your complex numbers in cases where the roots are non-real. Remember, in mathematics, we stop where we are saying non-real, but with you technical mathematician, we know that if you are having a square root of a negative number, that is a complex number. You now bring in your complex application in order to solve that quadratic equation. And then now let's look at the first few examples there. The first one, we are given an equation minus 5x minus 4 plus 4x squared. Look at that sequence, grade 12. Can you see that it is not in order because it must start with an x squared followed by x and then a number which is a constant number, right? So now let's rearrange now this in a correct order. So we are going to start with 4x squared followed by minus 5x followed by minus 4, that is equals to 0. Happy now? We are in a correct standard form of our quadratic equation. And then now we can identify the values of a now. What is a? A is a value that is a coefficient of x squared. In this case, it will be 4. And then the b value is the value that is the coefficient of x, which is minus 5. And then the c value is the constant value without an x, that is minus 4. Can you see, grade 12? I am taking the whole value with its sign. You can't leave that minus out. Okay. And then now let's look at the second one again. We are given x into 7 plus x equals to 0. And then now, if you look at this, now we are having a bracket. You can go straight and solve the problem, or you can multiply the bracket out and identify your A, B, and C. Because in this case, they want us to identify A, B, C. That means we will need to multiply the bracket out. So now when we multiply these two, it will be 7x there. And then x times x, it will be plus x squared, which is equal to 0. Can you see the order now? It's not according to the order that we need. We must start with x squared. So we will rearrange this to x squared and followed by 7x. Can you see we don't have the c value there? This is equal to 0. There's no c, so that means your c value is 0 there. Okay, so now when we identify the a value for this one, it will be 1 because the coefficient of x squared is 1. And then coefficient of x is b, which is 7. And then the c value will be 0 then. And then looking at the last one now, we are given 2x squared minus 8 equals to 0. Still, we have to identify the a, the b, and the c value, and we have only 2 terms now. Let's see now. Oh, something with x is missing there because you must have an x squared and x and then the constant value there. So now, where we don't have a value, we'll replace that value with a 0. That means it will be 2x squared plus 0x minus 8 equal to 0. What is the a value? The a value is 2. The b value is 0, grade 12. That is why we don't have a bx there, okay? And then now the c value will be a minus 8. And then now let's say we are solving for x. Let's start with the first one. We are solving for x. That means the first thing that you do is arrange in standard form, identify the value of a, b, c, and then now you can take your quadratic formula. As you can see, it only needs a, b, and c in order to solve for x. Then we are going into the quadratic formula. We are going to substitute our values now. The value of b then, it's a minus 5. But this formula on its own is having a negative there. So you'll be having a negative from the formula and the negative from the value of b. Can you see, grade 12 is 2 negatives now. The first one is from the formula. The second one for the value of b. They must both appear in your substitution. And then you have a plus minus in between, as you can see there. And then inside the square root, we are having b squared minus 4ac. Again, we bring back that b, which is minus 5. Substitute squared. minus 4. Please ensure that you copy the formula correct from the formula sheet, grade 12. This is a minus 4 into the A value, positive 4. Can you see now? You just substitute from your data now. The value of C, minus 4. All over 2 into A is 4. And then from here now, grade 12, you can put everything into your calculator now. Can you check that for me? I need the simple set form of this before we go identifying the x values now. We must indicate the simple set form of this. And then this will be plus 5 with the plus minus the square root of, how much did you get there? From your calculator, it says square root of 89 over 8. Right. And then now you press your SD button because you want this in a decimal form. The first x value will be 1,80. Why are we rounding to 2? Because there's no statement that is indicating to us that round to a certain decimal. We are following an instruction from the beginning of your question paper that says that round all your answers to 2 decimals unless stated otherwise. So now we are having 2 solutions here. It's the plus and the minus 1, grade 12. It must always be 2 solutions. So we have the first one, 1,80, and then the second one will be minus 0,55. So now the first mark will be for substituting into the correct quadratic formula, the second for the simple set form, and then third for the first rounded correctly, and the fourth one for the second. It must be correctly rounded off, grade 12. 2 decimal places after a comma. Thank you. And then now let's look at number 2. This is the second problem. We have 2 ways of answering this. Other learners may see that at this level, they have already factorized for you. A learner might go straight from that one and say the first x is equal to 0 on that one. And then in the bracket, learners can say, oh, another x will be x equal to minus 7. Okay, if you can't see that, grade 12, remember the quadratic formula will always assist you. You are still going to substitute your A value, your B value, and your C value into what? Your quadratic equation. So that means this will be x equal to a minus from the formula. And then our B is now positive in this case. We put a 7 for B there. And then it's plus minus. Remember, in the square root sign is the same. B value 7 squared. And then minus 4. And the A value is 1. C value 0 there. And then all over 2 into the A value 1. Everything into your calculator, grade 12. Then it will give you the same solution that x will be equal to 0. Or you change now plus minus, it must be a plus equation, and then you check the minus equation. Then it will give you exactly the x equal to minus 7 as your second solution. So can you see quadratic will assist you a lot if you are not comfortable with factorization. You can do all your factorization using quadratic. Now, when looking at this one now, here, some learner may see that there's a common factor 2. That is the first method, grade 12. A learner may see that there's a common factor 2 here and decided to divide through by 2. So if you divide here by 2, you'll be left with x squared. You divide minus 8 by 2, you'll be left with minus 4. You divide the 0 by 2, you'll be left with 0. And if you look at this now, you're having a difference of 2 squares. Why? Because a 4 can be written as 2 to the power 2. That is why we are saying it's a square number. Okay? So if it's a difference of 2 squares, it means now you'll be having 2 brackets of the same thing with x minus 2 and the x plus 2 as your factors. So the first x will be 2 or x will be minus 2. That is the first solution. That is how you can present the solution to that quadratic. Then if you are still following the quadratic equation of which you'll be doing in all your factorization, This is the method where you are adding a 0 for the one that is not presented. So, right, the b value is not there, so you are going to put a 0x for them. So now we can now go to our quadratic. X is equal to minus b. What is b? 0 plus minus, what is b? 0 squared minus 4. What is a? 2. And value of c minus 8. And then all over 2 into 2. Grade 12, if you put this into your calculator, it will give you exactly the same solution, that x is equal to 2 or x is equal to a minus 2. Okay, can you see? I have applied quadratic in all the solutions. So that means with quadratic in all your quadratic equation, it is possible to just rely on the quadratic equation. And then now we have quadratic inequalities now. Inequalities, the difference is that if it's an equation, it's having an equal sign, but if it's an inequality, it's a greater or less than, or it's a greater than inequality, or it's a less equal or a less than inequality. So the tip is that apply the same factorization method as in equations. That is the same thing that we have done when we are solving for x on the previous activity, you also apply on inequality. This is assisting you to find the critical values, because this is not an equation. You cannot treat it as an equation, grade 12. We are solving inequalities. So now, whatever values you get as being with an equal sign, you must know those are critical values. They are not yet your solution. And then remember also that when you multiply or divide by a negative, this negative reverses the inequality sign. That means if my inequality sign is greater than or equal to, the minute I multiply by a negative, it will become less than equal to. The same applies if it is greater than, it will be less than. Only with the multiplication of a negative or division by a negative, not transposing, grade 12. If you transpose, you are not having any impact on your inequality sign. So now, after the critical values, you must represent the solution graphically before you conclude the final solution. That means your final solution is determined by the graphical presentation. You can't go straight to the solution without showing that part of graphical presentation. Let's see now what is expected of us. Now, if we try to reverse this, grade 12, can you see this will be 6x minus x squared. With inequalities, it's a challenge if you are having an x squared being negative, because now it is having that impact on the inequality sign now. So guard against that one, grade 12. If you look at the first one, it means the inequality sign will be affected because our x is negative here. Guard against your x's, okay? So that means we need to change this x to be positive so that we can end up with a positive x squared there. So now we are going to multiply this bracket with the negative bracket only. We leave x out, and then we multiply this bracket with the negative. So the negative x will become positive x. I'm also rearranging this in order. And the positive x will become the minus 6. Okay? And then now inequality sign will now be less than equal to 0. Why? Because I have multiplied this with the negative. So that negative is having an impact on your inequality sign. Now we can now look at the critical values, grade 12. We criticize the values because we are going to say equal to. So now it will be x equals to 0 as we are solving your equations, or for the bracket, it will be x equals to 6. These are critical values. We can't say it's the final solution because we are solving for an inequality. So now we are going to represent this on a number line. Some of you are using parabola function, others are using a table method. Any method that you are comfortable with, grade 12, as long as it is correct, you may use that particular method. Now let's represent the critical values on your number line. We always start with the smaller number, which is 0, followed by the bigger one, which is 6 there. And then if you look at our inequality sign is having an equal sign there, that means these values will be included, will be having a shaded dot there, meaning that 0 and 6 are part of your solution. And then if you look at this, the inequality sign is less than. Can you see it is close to x there? It is close there. That means it is less, okay? And then if it is less now, shading will be in between. Less than, okay? If we shade greater than, we'll be going this way. We are growing greater than, growing greater than. So your inequality sign will be open to the x values now in that case. Because they are now close, that means it is less than. We are shading coming together like that, coming in. So in this case now, we are sharing the values because we come in, and therefore your x will also be shared. Amongst your values, here will be 0, and then this one will take a 6 there. And then because you have an equal sign, it will be x greater and equal to 0 and x less and equal to 0. That means your solution is between 0 and 6 for the values of x of this particular inequality. Great job. Okay, let's look at the second one now. In this one, we are given 2x squared plus 6x is greater than 0. Can you see the common factor again? Yes, we can now divide by 2 throughout to simplify our expression, or our inequality. And then now when we divide by 2 here, we'll be left with x squared. And then 6 divided by 2, that is 3x. And then remember, this is greater than a 0 there. Okay. And then can you see a common x now? Okay, we take out x being common, or you can go your quadratic as we did on the previous question. Our c value will be 0 here because we don't have a constant value. Can you see that? Okay, or you can take out a common factor x, and then if we take 1x out here, we'll be left with only 1. Okay, and then on 3x, we take out x, we'll be left with plus 3 because we have taken that as being common there. And then now we criticize the values because we are going to use an equal sign now. The first x value will be x equals to 0, or the bracket one will be x equal to m minus 3 when you transpose that positive 3 into a number line. We have our number line starting with the smaller value, grade 12. Which one is smaller between 0 and minus 3? That is minus 3. Think about your number line. Values on the left are negative, on the right they are positive. So that means 0 is in the middle. So when you go negative, you are less than. So we start with minus 3. It will be smaller than 0. Okay? And then now look at the inequality sign. Does it have an equal sign? No. So if there is no equal sign, the values are excluded. Then it will be an open dot. Minus 3 and 0 are not part of the solution. But we are taking everything that is greater than, because we are looking at the greater solution. Can you see the inequality sign? It is now open to your x-axis. That means it is greater than. Open, greater than, right? The minute it is greater than, we are shading out. We are growing this way, greater, growing, okay? So that means we will be having shading to this direction. So in between, there will be an or, open or, okay? Open from the inequality sign, there's an or in between, which is leading us to the solution. So the minute there's a gap in between, that means you'll be having two x values greater now. Can you see the difference? Here we are sharing, x is in between, but with the second one, there's a separation with an or in between because we are shading greater than. And then now x will be less because it is taking all the values that are less than the minus 3 there. And then this side x will be greater than because we're taking values that are greater than 0. That is the notation greater. And then now the first mark will be for correct factors, the second mark for correct critical values for 0 and minus 3. And then the third mark will be for the first inequality solution, and then the fourth one will be for the second one. So this question may worth up to 4 marks, great jobs. So that is how you do your inequalities. So it is having a relationship with your quadratic equation factorization. And then now followed by simultaneous equations. In simultaneous equation, we'll be solving for two unknown. It can be x and y. It can be p and q. It depends on the examiner which letters wants to use for that particular simultaneous equation. And then now when you look at those two equations, you need to compare your equations, great ones. Make one variable from the linear equation. That means you compare the two equations. If there's a one with an x square as an exponent, you avoid that one. You look for the one with x to the power 1 or y to the power 1. So we take that one as being the linear equation. And then from the linear equation, you make one variable be the subject of the formula. And then after that, you substitute that into quadratic equation, the second equation, and then you solve. And then for the second variable, you substitute into the linear to get the second solution. Remember, you are solving for two unknowns. If it is x and y, you need to have values for x and the values for y. Let's take an example then. Okay, we are having the two equations given to us here. The first one is y minus 5x plus 2 equals to 0. And the y equal to x squared plus 4x minus 8. We need to solve for x and y in those two equations. Remember, the method says make one variable from the linear equation. So we are going to compare these two equations now and check which one is the linear one, the first one. So from the first equation, we are going to make one variable the subject of the formula. So if you compare the two, we are having 1y and then minus 5x. So we'll rely on 1y to be the subject of the formula to make your life easy. Always target the one with the coefficient 1 if possible. Now we are going to leave y in equation y and transpose minus 5x and 2 to the side. So minus 5x to the right will be positive 5x. A plus 2 will be minus 2. That is the new equation that we have created. And then now after making subject of the formula one of the variable, you are going to substitute that equation now on this quadratic equation. So you take the one that you didn't use, grade 12. That means we are taking y is equal to x squared plus 4x minus 8. And then where we are having a y, we are going to substitute 5x minus 2. Oh, we have a y here. That means this y will now change and take what? 5x minus 2. Let's substitute y is 5x minus 2 equal to the x squared plus 4x minus 8. Can you see now after substitution, you'll be having only one unknown. Whereas in this equation, you were having two x and y on both equations. But after substituting now, can you see now our equation is now with one unknown, which is x. And then I'm targeting the x squared because it's on the right. I'm going to transpose everything to the right hand side. So leave x 0 on the left. So as we are transposing, we add like terms and then also consider the order now of standard form, x squared, x, and the constant value for quadratic. So x squared, that is the only x squared we have. And then we have a plus 4x there. And then we take 5x to this side, it will be minus 5x. We leave a minus 8, we take minus 2 to join minus 8, it will be plus 2 there. So you have 0 on the left, now we have x squared. Plus 4x minus 5x, it will be minus x. And then the minus 8 plus 2, it will be a minus 6. Okay, and then now grade 12, can you see now you have a quadratic equation of which you need to factorize. It is talking to you, it says that look for factors of 6. When you subtract them, they must give you minus 1. Remember, when you talk factors of 6, we are talking 1 times 6, we talk 2 times 3. Those are the only possible factors for 6. And then now, out of these factors, you want to select the one that are talking to this trinomial. It says factors of 6 when you subtract, you get 1. Can you see grade 12? You can't take 6 and 1 because when you subtract 6 and 1, you'll get a 5. So the correct one is 3 and 2. So you can't just write any factors. You need to understand the trinomial request and address it accordingly. Okay, and then in this case now, our factors will be 2 and 3. X squared we share equally, then we have for 6, we take 2 and 3 there. Because we need a -1, the bigger one must take a negative, and then this will be positive, so that we end up with -1 when we end. So now the first X value for the first bracket will be X, we transpose positive 2, it will be -2, or X will be equal to a 3. Happy grade 12, but up to this far, we have only the X values. Remember, we are solving for both X and Y. Do not forget that you are solving two unknowns, okay? So after finding the value of X, you now need the value of Y. To make your life easy, take this equation that is stating Y is equal to already for you 5x minus 2. Then you substitute your first X value. We are taking X equal to -2. That will be 5 into -2 minus 2. That is -10 minus 2, which is minus a 12. So that means that -2 coordinates with -12. So that is the first Y value. We need another Y value. We are going to take the same equation, Y equal to 5x minus 2. We are now substituting X equals to 3. So it's 5 into 3 minus 2. 5 times 3 is 15 minus 2. 15 minus 2 is giving us how much, grade 12? That is the 13, yes. And then from here now, we can write in coordinate form, which is 3 and 13. If X is 3, Y will be 13. Basically, those are the solutions for the simultaneous equation. And then let's look at the mark allocation now. The first mark will be for this third equation that you have derived from the linear equation. The second mark will be for substitution now into the quadratic equation. The third mark will be for the correct trinomial. The fourth mark will be for the factors. The fifth for X value, first one, 61 for X3. And then some examiners, they give 1 mark for both Y values, or they can give each of the same mark. So 2, 4, 6, 8, 9. This question can worth 6 to 8 marks depending on the examiner controls. Okay. 6, 7, 8 marks. Right, we are still on equations on algebra. We now look at the literal equations. When you talk literal equations, your equation will be presented in terms of letters in most cases, right? Not as in Y equal to X, as we are used to straight line and the parabola and so forth in functions. Literal, it can be any equation related to real life technical problems, okay? And then they will be integrated in this topic, literal equations. And then mostly we will be taking them from your trade subjects, that is mechanical, civil, or the electricity or electronics and so forth. Sometimes we take formula from your technical science and then apply it in this topic in mathematics. Right, and then let's look at the example now, type of equations that we are talking to. We are given the following formula represent the relationship between capacitive reactance, frequency, and the capacitance. Okay, capacitive reactance, frequency, and the capacitance. And then this is the formula we are talking to. That is the capital XC equal to 1 over 2 pi F capital letter C. And then now here they have explained to us the representation of each letter there. So they say this capital X with smaller c there, it is a capacitive reactance. And this is calculated in ohms. Ohms, remember we are talking that sign, okay? From science, okay? And then we have the frequency. This F cursive is for the frequency, that is calculated in hertz. Remember, sometimes we use the HZ in our technical science. And then the C is for capacitance. Capital C is for the capacitance. And then this is calculated in farads. Okay. Now, these are the types of equations that I'm talking to now. They will be letters, but they will explain each letter to you. And the first question now, you need to express F as the subject of the formula. From this equation given to us now, we want to express this F here to be the subject of the formula now. So it's so simple, grade 12 now, because we want to remove only this F from the denominator. Remember, this is over 1. So we can cross only F to this side. And then as we are crossing F, we can also cross XC down there with cross multiplication. And then 1 will cross to that one. That is 1 times 1, still 1. So now let's see what is happening now. As we cross F, it will come to this side. That is our number 1. And then 1 times 1 on top there, it will still give us the 1. And then on the denominator, we are left with 2 pi capital C. Remember, we have crossed F. And then this XC will come down there, cross multiplying to that position. So that is all we are expecting from you, grade 12. This is F as a subject of the formula, right? And then number 2, hence determine to the nearest integer the numerical value of F in hertz. If we are given the XC value, that means the capacitive reactance in ohms, and then we are given the capital C, which is the capacitance in farad. And then now we need to calculate F in hertz. So now, since they say hence, they say using the previous solution. So our previous solution is F is equals to 1 over 2 pi capacitance, and then X with capacitive reactance then. And then let's substitute grade 12. We have 1 over 2 pi. And then what is capacitance? That is 50 times 10 to the power minus 5. And then multiply by the capacitive reactance, which is 63,66 ohms there. And then we'll consider the units at the end of the solution. And then when you look at frequency of this, it is giving us the 5 hertz. Or you can just put that symbol for hertz there. And then the mark allocation for this one, it will be, remember from the first question there, we will be having 2 marks for manipulating this correctly. So, and then now, second problem, it will be 1 mark for substitution. And then the third mark, the second mark for the correct answer there. So this will worth only 2 marks because you are just substituting into the formula into your answer then. And then still on algebra, in some cases you can have log, surds, exponential equations, or expressions to solve. It's either they will give you an expression to simplify, or they will give you an equation in terms of logs, surds, or exponential equations to solve. And then now, what do we apply here? In order to solve log, surds, and exponential, they have certain laws or rules that you need to follow for all 3 of them. So to simplify your expressions and to solve your equations. So you need to know those rules greater before you can attempt these types of questions. So the first one, we are given the log 5 is equals to m. We are given that if log 5 is equal to m, determine the following in terms of m now. That means you can't have an m if you don't have log 5, right? So you must always fight for a log 5 in all 1.1 and 1.2 problems. So now 1.1, we are given log 25. Remember, we are looking for log 5 because you can only substitute m if you have for log 5. So now we are going to change this log 25. Now remember, 25 in exponential with prime base is 5 to the power 2. So this will be equal to the log of 5 squared, and then which is the same as 2 log 5. Can you see now we have created a log 5? That means you are going to remove this log 5 here and substitute with an m. Therefore, that is your solution for that one, Charles. Okay. Moving forward to 1.2. In 1.2, we are given log 2 now. We are looking for log 5. How can I create a 5 from 2? Right. You know that if you have a log 2, that means it's the same as log 10. If you take 10 over 5, do you agree, grade 12, we are still having a 2? 10 over 5, it's a 2. So you are going to represent this 2 as the log of 10 over 5. The aim is to create a 5, remember? And then now from here, we apply the rules of logs rules. If you are dividing a log like that, the rule says you can write it as log 10 minus the log of 5. Okay, reversing this back to its original. And then log 10, remember if there is no base, there's a base 10 there. That means this is log 10 base 10 there. So log 10 base 10 will give us a 1 minus the log of 5. Can you see log 5? Happy, that is m. That means our answer will be 1 minus m for that one. Because we are writing everything in terms of m. Number 2, solve for x. We are given that the log x plus 3 base 2 minus 3 is equal to minus log x minus 4 base 2. And then if you look at this now, we target the logs, they must be on the same side. And then values without logs, we take them to the other side. That means now we will have on the left log x plus 3 base 2. Then we take this log to the side, it will be plus log x minus 4 base 2. Then we take a 3 to the right hand side, it will be equal to positive 3. And then when you look at the left hand side, you can see that you can write that as a single log by applying the log rules. So when we are adding 2 logs, taking this to a single log, it means you are going to multiply the bracket according to the rules. So you'll be having only single log, but now we'll be multiplying x plus 3 and x minus 4. That is the rules of logarithms. Remember our base is base 2. Still have that base. This is equals to the 3 on the right hand side. Right, now we are multiplying the 2 brackets here. X times x will give us an x squared, and then x times minus 4 is minus 4x. 3 times x is 3x. Minus 4 plus 3, it will be a minus x thing. And then the outer ones, 3 times minus 4, that is 4, 8, 12, that is minus 12. Only the bracket, they are giving you that trinomial. But remember, you still have this log here. In order to get rid of that, remember the rule of log equations. It says if you take that 2 to the side, it will be 2 to the power 3. Can you see it has keyed that 3 to an exponent now? It will be 2 to the power 3. That means we are having x squared minus x minus 12 equals to 8 now. Transpose an 8 to the left, that will be x squared minus x minus 12 minus 8, that is minus 20, equals to 0. Can you see a quadratic equation is playing a major role? We now have a quadratic equation to factorize. So you are looking for factors of 20. When you subtract them, you get a 1. Remember, it's 1 times 20. Is 2 times 10. We are looking for the one that is giving us 1, right? And then we have 4 times 5. Can you see 4, 5 will give us a 1? There's no way 2 and 10 can give us a 1. There's no way 1 and 20 can give us a 1. The correct one will be 5 and 4. Can you see grade 12? I do not just take any factor and decide it is correct. You must test until you get the correct one. So correct is 5 and 4. That will be factors of 20 being 5 and 4. And then this x here we share equally, x times x, which is x squared. The middle term is negative. It must take the sign of the bigger number because you need a -1. Therefore, 4 will be positive. So the x value for the first bracket will be x equals to 5 or x equal to a -4. And then this -4 will not be a solution. Why? Because when you put a -4 here, it will be -4 plus 3, which is -1. The log of a negative number is undefined. Therefore, that is why we are stretching off that x cannot be a -4, cannot be a -4. Okay, the log of a negative number is undefined. And then 3.1. Question 3, we need to simplify without using a calculator. Without using a calculator, without using a calculator. Okay, we are using our exponential laws, the surds, logs, and so forth, and the knowledge that we have of simplifying expression without using a calculator. You can use a calculator just to check whether 3 to the power 2 is it 9. 3 to the power 3 is it 27, just to check whether your exponent is correct. That's it. But you can't rely on a calculator to give us the solution. So with 3.1, we are given 81. A to the power -8 is to the power, all of that to the power -3/4. That means this exponent now, -3/4, is for 81. It is also for an a to the power -8. Now you're going to start by writing 81 with its prime base. That is the simplest way of answering logs, the surds, and the exponent. Target the base is to be prime bases. For a prime base for 81 is 3 to the power what, grade 12? To the power 4. So we are going to write this 81 as the 3 to the power 4. And then we bring in its exponent. Remember, -3/4 is for both of them. I'm just separating it so that each base can take the exponent. So in A, we are having a to the power -8. Each base is now taking the exponent. And then from here now, remember this is over 1. We are simplifying only the fraction on top. You can even test with your calculator. Are you correct? And then the 4 will cancel a 4 there. Then it will leave us with 3 to the power -3 multiplied by. And negative, remember this bracket is multiplication. Negative by negative, it will be a positive. And if 4 goes once there into 8, it will be 2 times. That means we will end up with a to the power 2 times 3. Remember, negative by negative, it's a positive. That means it will be a to the power of 6. Right. And then we now have a to the power of 6 over, because this one is negative, it will go below. Or you can write it as 1 over 27, a to the power 6. Or you can write it as a to the power 6 over that 27. Okay. Lastly, grade 12, we are looking at the surd now. The surd problem that we are having there. So with the surds, remember, you must start writing everything in a simple surd form. Can you see you have something in common there? Look at this, 2 to the power n, that is trending there in all your terms there. So that is the common factor that we are identifying. But before we can take that common factor, we are going to simplify our surds, the square root of 32, square root of 2, and the square root of 50, and check, is there any other common factor on those again, right? And then now let's start grade 12s. We are having 2 to the power n, yes, equal sign there, multiply by, in the square root sign, we are having 32. 32 is the same as 16 times 2. You must look for a number that is a number with the square root and then multiply by the simplest prime base of that particular number that we are having. Also, we are also guided by the square root 2 there. So now it means in 32, we are going to write 32 as 16 times 2 plus 2 to the power n. This one we leave it because it is already at square root 2. And then denominator, we have 2 to the power n. and the square root of 50, a number that is having a square root is 25, multiplied by 2. Can you see now we have generated 2 in the square root sign? And then now from here we have 2 to the power n, and then we take this 16 out here, it will be 4. So we will be having multiply by 4, multiply by the square root 2. That is for the first term. And then for the second one plus, we have 2 to the power n, the square root of 2, it's fine. And then denominator, we have 2 to the power n. And then the square root of 25, we are going to take this out because we know square root of 25, it's fine. And the square root of 2. Can you see the common factor greater? We have square root of 2 with 2 to the power n. Can you see that? Square root of 2 to the power n. 2 to the power n square root of 2. So we are going to take that as being our common factor. 2 to the power n plus the square root of 2. So when you take 2 to the power n square root of 2, you are left with 4. Plus, for this one, 2 to the power n and the square root of 2. If it cancels everything, it's like 2 divided by 2, it's a 1. It's not a 0 greater. 4 divided by 4 is a 1. 1,000 over 1,000 is 1. So that means here we are left with a 1, not a 0. And then denominator, we take out 2 to the power n with the square root of 2, 2 to the power n square root of 2, we are left with 5. Can you see now, this common factor can cancel that because you are multiplying. So you'll be left with what, greater? 5 over 5, which is just a 1. So with the surds, you target the common factor if you are adding and subtracting surds. Write your surds in the simplest form before you can decide. Okay, now another topic. Grade 12, this topic, you did this topic at grade 10, but it will be tested in grade 12. You only do it once in grade 10. Go back to your grade 10 books and check. We are talking binary numbers. Binary numbers, we work with 1 and 0 only, no any other number. Presentation of a binary, we use 1 and 0 there. So they can ask you to add, to subtract, to multiply, or divide binary numbers. You must be able to do so. So now we are given the binary number P is equal to 1010 base 2, and then Q is equal to 10000 base 2. And then now number 1, we are expected to add these binary numbers. It's fine, you can change them to decimal and work with the numbers that we are used to, and then after adding them, change your solution to binary. It is also acceptable, grade 12. Any other way that is more easier for you. Right, and then let's go. The first one, we are adding P plus Q. What is P? P is 1, 0, 1, 0. I'm leaving that base 2. We know there's a base 2 there. We'll attend to that later on. And then we are adding this to Q, which is 10,000. That means we have 3 zeros there. And then with the 1 and 0 here. You still remember the rules? When you are adding 0 and 0, it will be 0. When you add 1 and 0, it will be 1. When you add 1 and 1, it will be 1 carrying 1 to the other side. So we are only working with 1s and 0s, grade 12. 0 plus 0, 0, 1 plus 0, 1. 1 plus 1, it's a 1 carry 1. Okay. Right, and then here we have 0 plus 0. Remember, we are adding the 2. That is 0 plus 0, 0. 1 plus 0, 1. 0 plus 0, 0. 1 plus 0, 1. And then 1. That is the only one we have there. So that is your answer, grade 12, with the base 2 there. Okay. And then the second one, you are taking Q. What is Q? Q is 10. It's 10000 base 2 minus P. P is 1, 0, 1, 0. And then in this case, we are now subtracting, no more adding. We are subtracting. Now, when you subtract 0 by 0, it's fine. It will still be a 0 now. No problem with these two. Now the answer will be 0. But here we have a challenge now because 0 minus 1, you need to borrow something. You can't subtract 1 from a 0. Okay, so now we go back. We don't have anything there. We don't have anything. We need to borrow from this one here. Okay, and then when we borrow that one, it will come off to this, and then as they come to the next unit, it will be 1 1, not 11. Grade 12, we are talking binary. This is 1 1. Okay, so when it appears as 1 1 in the side, we borrow 1 from that one. So when we borrow 1, when it comes to this side, it will be 1 1. Okay, we borrow another one because we want to move to the one that is having a 1 there. We cancel that, it will be 1 1 there because we have borrowed. Can you see that when you borrow, it now comes as a 1 1, borrow 1 1. So we have 1 1, we minus 1, we'll be left with 1 here. Okay, remember you are left with 1 here. As you were borrowing that one, then it's 1 minus 0, it's 1. And then here it's 1 minus 1, which is a 0 there. So your answer will be 1 1 0 for this binary subtraction. Okay, that is your answer for addition. You can put the base 2 there. It's fine. Even if it is not there, we know there's a base 2. And then the multiplication now, let's look at when you are multiplying. So we are multiplying a P times a Q. Remember, 4 times 2 is the same as 2 times 4, grade 12. 4 times 2 is 8, and the 2 times 4 is also, it doesn't matter you start with which one. So I want to start with the longest one, which is Q. I'll put that on top. That will be 10, not 10, 1, 0, 0, 0, 0. And then we are multiplying this with 1, 0, 1, 0. In this case, we are now multiplying. You apply the same method that we've been using at your earlier grade, that will be multiplying everything with 0 there. Okay, the first 0 here will multiply throughout. That means we'll be having 0, 0, 0, 0, 0. Any number multiplied by 0 is a 0. The same applies here, grade 12. And then now we are now multiplying with the 1. 1 times 0, it will be 0. 1 times 0, 0. 1 times 0, 0. 1 times 0, 0. 1 times 1, 1. Okay, these are zeros. Okay, we are done with that one. We come to 0 now. 0 multiply everything, it will be 0, 0, 0, 0, 0. Okay, 1, 2, 5 of them. 1, 2, 3, 4, 5. Can you see we are moving to the left? Okay, we are done with the 0. We now multiply by 1. 2 times 1 is 2. That means anything multiplied by 1 will be the same thing. So that means we'll take that 1, 0, 0, and bring it down because we are multiplying by 1. Okay, that will be below 1. That is 0, 0, 0, 0, 1. We are taking this expression because it is multiplied by 1. And then now, after multiplying, we can now add whatever you are having. So you bring, this is the only 0 there, and then 0, a 0 there. I hope you are still with me, grade 12. Give us a 0, 0, a 1, because there's a 1 there, and then a 0, and the 1 there. So that is the product of those two. 1, 0, 1, 0, 0. Remember, you have a base 2 there. Okay, that is how you do your addition, your subtraction, and multiplication of binary numbers. Can you see algebra? We are still on algebra, grade 12, your 50 marks that you need to master in order to pass your paper 1. So the next topic on algebra is nature of roots. This nature of roots is having a relationship with the quadratic formula. Remember, quadratic formula states that x is equal to minus b plus minus b squared minus 4ac over 2a, right? Can you see the discriminant is what is inside that square root sign? So it is having a relationship with the quadratic equation, quadratic formula, and then the nature of roots, okay? Quadratic function also. Now, we call this delta a discriminant in nature of roots. And then remember, the method is still the same. You need to write all your equations in a standard form before you start solving any nature of roots. Also identify the value of A, the value of B, the value of C. We now know how to do that, grade 12. And then now you must analyze the question after standardizing. You take out A, B, C, and then you analyze the question now. What is actually what are you looking for, okay? So for the first one now, it's either they will ask you to determine or to prove or show the nature of roots. If your question states determine or prove or show, you start by saying the discriminant is equal to b squared minus. That is your starting point. It will always be discriminant equal to b squared minus 4ac. But if the question states calculating the possible values, calculate the possible values of the unknown variable except x, that means in your equation that there will be a letter k added or what, and then you are solving for that k. But you will be given roots, the type of root that will be given. For example, if they say the roots are non-real, your discriminant will start saying discriminant less than 0. Can you say a difference? You start with the given roots. It's not like determining. When you determine or you prove, you start by saying discriminant is equal to b squared minus 4ac. Right, let's look at the first one now. We are given the x squared minus 2x plus 6 equal to 0. And they say without solving the equation, determine the nature of roots. I said to you, the first thing you check, is it in standard form? Yes, happy now is x squared, x and a constant value. Can I take out the a, b, c values? That is the second method. Now you need to take out the value of a, which is coefficient of x squared, that is 1. The value of b, coefficient of x, that is minus 2. The value of c, that is equal to 6. I have done so, taking out the a, b, c. And then now, without solving the equation, determine the nature of roots. Can you see it says determine? Determine, we said we start with the discriminant is equal to b squared minus 4ac. Okay, I hope we are still together, grade 12. What is the b value now? We are now substituting. B is minus 2 squared minus 4a is equals to 1, and the c is equals to 6 from your data there. And then now into your calculator, straight to the answer, grade 12. How much is your answer there? That will be minus a 20. Can you see your discriminant is now less than, it's negative. If it is negative, that means it's less than 0. Check your number line. Negative values are less than 0. Therefore, this discriminant is what? Is less than 0. And then now they say determine the nature of roots. If it is less than 0, the roots will be non-real, or for technical mathematicians, it will be imaginary. It's where now we involve the complex numbers when we are solving for x, okay? And then number 2, determine the numerical value for k, for which the equation x squared plus 2x minus is equal to minus k will have real roots now. The method doesn't change, grade 12. Remember, we said firstly, you must arrange your equation in a standard form. Check, is it in standard form? No, because k is on the other side. To be a standard form, it must be equal to 0 on the right hand side. So now let's rearrange in standard form. It is x squared plus 2x, and then follow that minus k to the side, it will be plus k equals to a 0. This is now in a standard form. It's just that our constant value is k now, okay? And then now from here, we take out the next step, says identify values of a and b. We are still doing the same. We identify the a value here, which is 1. So our a will be 1. And the b value will be positive 2. And the c value is now represented by k. Okay? Now read the question. It says determine the numerical value of k. if you are calculating the value of the unknown, you start with the given roots. Let's check what is given to us. They say for which the equation will have real roots. When are we having a real root? It's when our discriminant is greater and equal to 0. That is for real roots. Okay. And then this discriminant stands for b squared minus 4ac greater and equals to 0. Can we now substitute what is b? B is 2 squared minus 4a is 1, and the c is k greater and equal to 0. Remember, you are determining the value of k. We are solving for k greater. So 2 squared will be 4, minus 4 times 1 is minus 4, minus 4 times k is minus 4k. Greater and equal to 0. Remember, your unknown inequalities, keep it on the left neck to stop confusion. So we leave minus 4k, and then we transpose the 4, it will be negative 4. Now we are solving for k, we need to divide by negative 4 both sides. Remember, grade 12, I said to you, when you are dividing with the negative, you will have an impact on your inequality sign. So that means now this is minus 4 both sides. Therefore, we end up with the k. Inequality will change to less and equals to positive 1. That is your solution. Inequality changes because we have divided by the negative value. Right, we are still on algebra. Complex numbers, they still fall under algebra. As I've indicated somewhere, it will also appear in quadratic formula. Then they can be tested with quadratic equation. And then now, in complex numbers, we'll be expected to be able to add complex numbers, to subtract them, to multiply and divide them, to be able to determine the conjugate of your complex. Remember, if this is the original complex number there, my conjugate will be z. I will indicate on top with a dash there, that is now a conjugate. And if it's a conjugate, it's only changing the sign on the I part, so it will be minus bi. So this is the conjugate for this particular original. So you must be able to identify the conjugate of the complex number. You must be able to write your complex number in rectangular form with a real and imaginary number, which is this notation that we are having there. And then you must be able to write it in polar or triangular or polar form. Do you still remember that? It must say z is equal to the r is theta, something like that. That is the polar form, where you have to calculate the modulus and the argument before you can represent your problem in polar form. You must be able to represent the rectangular form in an Argand diagram and also be able to determine the resultant forces there. And then you must be able to solve equations simultaneously now, but with complex numbers. Okay, simultaneously, remember you did it with equations, but here we are doing it with complex equations now. Still, you will be solving two unknowns. So number one, we are given the complex numbers. Z1 is equal to minus 1 plus 3i. And then the Z2, the first one is in rectangular form. The Z2 is in polar form, which is square root of 2c is 135 degrees. And then we are expected, number one, to write down the conjugate of Z1. So now when we conjugate Z1, remember we need this with a line on top. The effect will be only on the I part, which is the imaginary number. So now when we take the conjugate for this one, Z1, it will be minus 1 minus 3i. Done, great jobs. That is what we are expecting of you. This will be 1 mark. And then 1.2, express Z2 in rectangular form. That means we are changing now from this type to this one. So can you see that Z2 is in modulus and argument? So we need to take it back to its rectangular form. How you doing that, grade 12? We are going to take this Z2 now, and then equal the square root of 2. Remember, this C stands for cos. The bracket there, cos of 135 degrees, and then plus the I sine 135. That is the abbreviation for that one. So we are taking this, expanding it back to its original. And then from there, we are going to look using your calculator. What is the cos of 135? You leave that square root there. And then the cos of 135 will give you minus square root 2 over 2. Check with your calculator, grade 12. And then the sine of also 135 will give you the positive square root 2 over 2, but there's an I there. Okay? And then from here now, we are going to multiply this square root 2 in each of this distribution there. So square root of 2 times square root of 2 will be 2 over 2, which is minus 1 there. You can also use your calculator to verify the answer. And then the square root of 2 into square root 2 over 2 will be 2 over 2, which is positive 1. That will be positive 1i there. So that is the 2 in a rectangular form. So the first mark will be for substituting correctly the cos 135 with square root 2 over 2 and the sine 135 with square root. And the final answer will be for the correct rectangular form. So this is worth 3 marks. And then 1.3, evaluate Z1 minus Z2 now. So what is Z1? Z1 is, so let's say Z1 minus Z2. Z1 is minus 1 plus 3i minus the Z2. Z2 is minus 1 plus I. And then now let's simplify and remove brackets. That is minus 1 plus 3i. A negative by negative, it will be positive 1. A negative times I is negative I minus I. And then the 1 minus 1 is a 0. And then the 3i minus I, it will be 2i. So that is 0 plus 2i. So the real number is 0, imaginary is 2 in this case. Right. Question 2, we are solving for x and y. If you are given the x plus yi minus bracket 1 minus I equal to 4 plus 5i. It's just one thing. It's not like in equations where we are having a linear equation and a quadratic one, because you'll be having 2 equations automatically. With a complex number, it's one line like that, but you are solving for 2 unknowns. So now how do we solve this one now? Let's remove the brackets, grade 12, so that we can have sense of everything. We have x plus yi minus 1 plus I equal to 4 plus 5i there. Okay? And then now we are going to leave the x and y to one side. Our unknowns is x and y, remember? We leave them to the left-hand side, x plus yi. And then we are going to transpose the minus 1 and the I, so that minus 1 can add to 4 and the I to 5 there. So minus 1 to the side is positive 1 plus 4, that will be 5. And then I, positive I to the right hand side minus I. 5 minus I will be 4i. And then remember, when you solve the complex equations, you are equalizing, you check the pattern. So if you look at this, the value that is not having an I is for x. So x will be equal to 5 in this case. So that is your first solution. And then remaining one, the I will take the one with the I. Can you see that the coefficient of I, it's y this side, so it will be equal to the value 4, which is the coefficient. So that is how you solve the complex equations with 2 unknowns terms. Simplify, ensure that your x and y, your unknowns, are on one side, everything to the other side, add like terms, and look at the relationship now to finalize your solution. Right, we are done with algebra. Can you see grade 12? There's a lot in algebra. go and ensure that you are mastering the algebra 50 plus minus out of 150 of your paper 1. And then now we take the differential calculus and integration now. First principle, we are using the formulas on the formula sheet, and then you will be penalized for incorrect formula or the incorrect notation. Ensure that you copy correctly so with all that we need out of the first principle formula. Now determine the derivative of x using first principle if f at x is equal to 3x plus 2. Grade 12 with the first principle, you only do the linear one, technical mathematics, and the answers are there. If you look at the first one, I am expecting my answer to be 3 here. After doing whatever first principle substitution, that is the answer. But now there is a method that you need to follow now. If you look at the equation, it needs your f at x, of which is what is given to you. It also needs f at x plus h. So that means you are going to identify this part of f at x plus h. How do you identify that? Wherever you are having an x, now we are going to substitute that with x plus h. For x, we put x plus h. And there's a plus 2 there. And then now you distribute 3 in each of this. That will be 3x plus 3h plus 2. That is our f at x plus h. Happy? And then from there, now we take the formula. We substitute in the derivative of x is equal to the limit of h approaching 0 of what? F at x plus h. So we take what? 3x plus 3h plus 2 minus the f at x. What is f at x? Bracket. That bracket is very important, grade 12. Ensure there's a bracket here because this negative is affecting both your numbers there. And then everything over h as indicated on the formula there. And then we are having the limit of h approaching 0. We want to remove the bracket now. We have 3x plus 3h plus 2 minus 3x minus 2 all over h. After removing the bracket, your f at x must all disappear. Look at this, minus 2 plus 2 minus 3x, 3x. All numbers that are not having h's must disappear. You must be left with something with an h only. That means we are left with only that part. So that will the limit of h approaching 0 of 3h over h, and the h will cancel an h. Your answer will just be a 3. And then look at the final answer. You don't write the limit anymore. This limit will appear in all your steps except the last one where you have an answer, because that will be a notation error if you put a limit there. So the first mark will be for f at x plus h. The second mark, correct substitution into the correct formula. The third mark is for removing the bracket correctly. The fourth mark for the 3h over h. The last mark for the h value there. And then the next one, can you see grade 12? I have projected that the answer will be 3. Am I correct? Yes, it's a 3. The same applies with the second one. We are projecting our answer to be half. Coefficient of x, nothing else. Ne? So we are projecting to be a half. So you start with f at x plus h equal to half x plus h. Only for x, ne? We are substituting x only. This is the pi, is not x. We cannot substitute into that one. Remember, pi is the number 22 over 7 or 3,14 and so forth. And then now this will be f at x plus h. So half in, half x plus half h plus 3 pi. That is f at x plus h. Into derivative formula, f derivative of x is the limit of h approaching 0. F at x plus h is this answer here. Half x plus half h plus 3 pi minus, how many times 2? We need a bracket. Half x plus 3 pi all over h. The limit of h approaching 0. Can you see that, grade 12? If you remove the bracket here, it will be half x plus half h, I'm repeating everything, plus 3 pi minus half x minus 3 pi all over h. 3 pi minus 3 pi minus half x. Can you see you are left with only values with h? It must always act like that. The minute doesn't go that way, that means you are going the wrong way, grade 12. So that h may cancel h, you are now left with only your answer, which is half. Can you see the method is the same throughout your first principle? So we are expecting you to get full marks for this one, grade 12. Our answer here, we are expecting it to be minus 8, coefficient of x. Now we start with f at x plus h again. So we are going to substitute x and x with x plus h. That will be 5 minus 8 into x plus h. So now our f at x plus h will be what? 5 minus 8x minus 8h. Can you see that? Your first mark is already there for f at x plus h. And then now we go derivative of f of x, the limit of h approaching 0. What is our f at x plus h? Is 5 minus 8x minus 8h. Multiply with the negative there, minus 5 plus 8h. 8x, sorry, that is 8x over h. 8x minus 8x minus 5 plus 5. So we are left with minus limit of h approaching 0. The ones with h's remain. You cancel everything, be left with only the ones with the h. Denominator is h there, grade 12, h cancel h. Then limit disappear on the answer. The answer will just be what? A minus 8. Can you see? It corresponds with whatever we were having there. And then now we have rules of differentiation. First rule, we have 3 rules. 1, 2, 3. The first one, if your f at x is a value, a constant value, the answer will be 0 for the derivative. If it's a constant number to x to the power 1, the answer will be the coefficient. Can you see? If it is x to the power 1, you take this value here to be your answer derivative. If it is something more than 1 at the exponent there, so you take the exponent, multiply by the coefficient, that is that part, and then from the exponent, you subtract 1 there. So that is the application of rules of differentiation. Now, grade 12, before you derive, you must simplify brackets and fractions as far as possible. Number 2, rewrite your sets in exponential form. Number 3, remove variables in the denominator to numerators. And then take note of the notations now. If your notation is f at x, the minute you start deriving, you want to see that dash there to show you are deriving. If it is given as y, the minute you derive, you want to see dy dx notation or a y with a dash there to show you are deriving. If it is given as dx, can you see now? It disappears. You only have your answer there. The same applies if it is given as dx. You only give us the solution without indicating any dx there. So now the first one, they say determine dx. We are deriving this in terms of x. So now this is controlling you in terms of the variable that you are having. You have p and x, but to the mere fact that they say derive in terms of x, will derive only in terms of x. You can't derive a p, grade 12, because we are deriving in terms of x. We check now, oh, there's no simplifying here. We can go straight to the answer number 1. And it will be equals to, we are deriving in terms of x, it will be 2 times 1. Remember, there's the 1 there, that will be 2. P to the power 3 remain like that because we are not deriving in terms of that. And then this will be x to the power. If it's a 2 on exponent, we minus 1, it will be to the power 1. So the first derivative is like that. And then the second one, remember the rule, it says if it is to the power 1, you take the coefficient. It is to the power 1, you take the coefficient minus 7. It's a constant value, it's a number, the derivative will be 0. So we are supposed to say plus 0, but we will not have that. We know there's a 0 there. So it's 1, 2 marks for the first one. Okay, look at the second one now. We have fractions. Remember, they say simplify your fractions as far as possible. No variables on the denominator. We have two challenges there. We have a fraction. Again, we have a variable in the denominator. And then what is going to happen is we are going to take this denominator and share it again to its original. It will be x over x to the power 7 for the first one, minus 3x squared over x to the power 7. We are still simplifying. I don't change the notation. I'm still having y on the left. And then now remember, this is x to the power 1 over x to the power 7. Dividing the same base, you subtract exponents. That will be x to the power 1 minus 7, which is minus 6. Minus 3, dividing the same base, x to the power 2 divided by x to the power 7. That will be x to the power 2 minus 7, which is minus 5. We have now simplified this. Is straight, no denominator, no fraction. We can now derive dy dx is the notation. So it's minus 6 times 1 there, that is minus 6x. From exponent, you subtract 1, that will be to the power minus 7. Minus 5 times minus 3, that is positive 15. X to the power with minus 1, that will be minus 6. If the examiner didn't mention that, write your answer in positive exponent, you can leave it like that. But if they say everything must be in positive exponents, that means this one, because it's the one that is having the negative exponent, will go back to the denominator and become positive. And then also this one, this will also only be affected because it's the one that is having negative. Then it will be x to the power 6 greater. So the first mark will be for the simplified equation, and the second mark for the first derivative, and the third mark for the second one. So this is worth 3 marks. And then now the number 3. Here we are having a set. Remove sets. That's cube root must be removed before you can derive. So now we are going to deal with that. We write the notation as it is. We are not yet deriving, we are simplifying. So this will be x to the power 2. And then this 3, when it comes here, it will be the denominator 3. And then plus 5 to the x to the power 4. This is now straight and forward. We can now start deriving. Notation, it stays. Put a dash there to tell us that you are now deriving. Still same method. Exponent times coefficient. 2 over 3 times 1 is 2 over 3. X to the power will be minus 1. That will be minus 1 over 3. And then 4 times 5, 10, 15, 20. And then x we minus 1 to the power 3. Get rid of negative exponents. That is 2 over 3. This x will go down there, join a 3 and become a positive 1/3 plus 20. And this one will remain like that. So it's 1 mark for writing this set in exponential form, 1 mark for the first derivative, and then another mark for the second one. No, this one is for writing this in an exponential form. That is 3 marks greater. Okay. And then still on the rules, we are having 2 brackets now. Now we come to the issue of simplifying brackets. Can you see you have a square bracket? The square bracket is for the notation. For this notation, we'll always go with the square bracket. And then inside that square bracket, you have round bracket with exponent 2. That means now it says multiply 2 bracket of x minus square root 2, square root x. And another bracket of x minus square root x. We are multiplying something like that. So now it will be x times x, which is x squared. We still have a d over dx there. Square bracket, that is x squared. And then the x times x to the power. Remember, x, square root of x is x to the power half. So if you say x times x to the power half, you are multiplying the same base, you must add exponent. It will be 1 plus the half, which is 1 1/2. Okay? And then now another x to the power 1 1/2. 1 1/2 is the same as 3 over 2. That means you'll be having 2x to the power 3 over 2. It's for these two and for that one. Okay? And then this is negative, not positive, then negative. And then add the last one, square root of x times square root of x, multiplying that, it will be plus just an x. This is now a straight equation you can now derive. The minute we derive, the dx will disappear. You apply the rule 2 times 1 is 2, x to the power 1. And then 3 over 2 times minus 2, it will be minus what? A 3. X to the power, we subtract 1 there, we'll be left with a half. And then now remember, if it is to the power 1, you take the coefficient, that will be plus 1. So that is our derivative. It's 1 mark for the simplified bracket, 1 for the first derivative, for the second one. So this problem is 4 marks straight out. Okay. And then now differential calculus and integration, we are still there. We look at the cubic function now. On sketching the graph, specifically this question is testing the sketching of a graph. They say write down, write. They don't say determine, you need to calculate. They don't even say calculate, they say write down. That means the answer is somewhere there on your question. So if you are looking for the y-intercept, you still remember you let x equal to 0, it will be 0, 0 there. Then if this is 0, everything here will be 0. Your answer will be y. Remember f at x stands for y. That will be y equal to 5. That means the y-intercept of this graph, it will be at y equals to 5. That is the answer for your number 1. Number 2, show that x minus 1 is a factor. To be a factor, when you substitute a 1, it must give you a 0. If it gives you a 0, that means it is a factor. So we are going to let this equal to 0, and then if we put minus 1 to that side, transpose, it will be positive 1. So we are looking at f at 1, where we have x, we'll substitute with the 1 into f at x formula, plus 3 into 1 squared, minus 9 into 1 plus 5. So into your calculator, grade 12, this is giving you a 0. Therefore, x, if it's plus 1, it will be minus 1, is the effect. That is correct. So it's 2 marks for that, 1 mark for y-intercept. And then question 3. Determine the x-intercept of f now. We now have one factor. Happy for that. We are having the first factor. So I'm going to apply the short method of factorizing a cube name. That will be x cubed. You can apply long division. You can apply synthetic. It's fine. It's up to you which one you are more comfortable with. And then minus 9x plus 5. That is our equation. Remember, when you solve an equation, you let y equal to 0, right? Because you are looking at the x-intercept, right? And then now we have the first factor here, which is x minus 1, which we have just proven there. So we need a trinomial factor for this now. So it will be x cubed divided by x, it will give us x squared there. And then you take the last term, the 5 divided by minus 1, that will be minus 5. So we need the middle term bx there. So I'm going to say now, the x minus 1 times x is minus x squared. That is the short method I'm applying grade 12 to factorize this. The x times bx, that will be bx squared. I only need those two, right? And then equals to, from my expression, my equation there, I'm targeting the x squared because I'm talking to x squared here. It will be equal to the 3x squared there. And then now, therefore, bx, I'm transposing the minus x squared to this side. It will be plus x squared plus 3, which is 4x squared. So can you see the b value is equals to 4 there? So now back to the equation. Remember, we have already from here concluded that it will be x minus 1 with the x squared plus bx, but my b is 4 now. I am putting back the b there, which is 4x minus 5 equal to 0. That is the short method of factorizing this without going long division. So it's x minus 1. We are looking for factors of 5. When you subtract together 4, that will be x plus 5 and the x minus 1 equal to 0. So x is equal to 1 or x is equal to minus 5. Can you see this is the same bracket? So that means there's no need to give us another x equal to 1. We already have that. So if your x-intercept is giving you two same x values, that means that x value is a turning point. The graph will turn at x equal to 1, grade 12. That is why it's giving us this same x-intercept there. So this is our x-intercept. And then now number 4, it says determine the coordinates of the turning point. Remember, turning point, stationary point, that is the derivative. So we need to derive this equation. The rules that we were doing on the previous question, we now apply them again. Is 3 times 1, that is 3. X, we subtract 1 from 3, that is to the power 2. And then 2 times 3 here, 6. And then from exponent, you subtract 1, that is to the power 1. And then this one is x to the power 1, you take the coefficient minus 9. It's your derivative. You let it equal to 0. And we can simplify by dividing by 3 throughout there. Divide by 3, you are left with x squared. Divide by 3 is plus 2x. Divide by 3 is minus 3. So we are looking for factors of 3. When you subtract, you get a 2. That is x plus 3 and the x minus 1. Therefore, x is equal to minus 3 or x is equal to 1. Remember, this is a stationary point. Can you see what I've said to you earlier on, that that x value will also be your turning point? That is why it's repeating on the x-intercept, okay? Now, after finding the x equal to 1, we have already done this one. To get the y value, remember, you substitute into original. That is the same method, substituting to original. Can you see it gives you a 0? That means the y value for this, it will be a 0. There's no need to do it again, grade 12. You can even do it in your calculator and give us the solution. So we'll do the same here. We are going to substitute the minus 3 into this cubic function where you are having x. Now we put a minus 3, and then this will give us the value of y being 32 here. Can you see now? We have the first pair here, which is minus 3 and 32. And then the second coordinate here is x1 and y0. And then when you compare the two, you look at the y values, you can see this one is the maximum one. That means your graph will be at maximum there. And then this one, 0, is smaller than 32. That means this will be the minimum turning point. This one will be the maximum turning point. It's very important to identify. It will assist you when you are sketching your graph now. So number 5, it says sketch the graph, clearly showing all the intercept, the axis, and the turning point. Okay, let's sketch the graph, Rachels. So now we need the y-intercept. We said it's 5 from there. Make a point there. You are having the x-intercept, which is 1, and minus 5. Minus 5 intercept and the positive 1, the intercept. And then we are having a turning point. We now address the turning point. Remember, we said minus 3 and 32. Minus 3 coordinating with the 32 up there. It's a coordinate because it's a turning point. So we are having a point there. And then this is telling you it's maximum. So we are going to have a graph turning the maximum. Okay, this will assist you, grade 12, to identify from there. And then now turning point again, 1 and 0 is minimum. That means this one will be facing upward, because then you can just join your point easy like that. Can you see now? We have a cubic function. It comes and 10 there. That is your cubic function. Right. And then now number 6, determine the values of x for which the graph of f is decreasing. When you look at them from the left-hand side, the graph is going up, is increasing. And then at stationary there at 32, minus 3 and 32, it starts going down. So that part is the one that is decreasing. And then from one stationary point there, it is now increasing again. So we are targeting the decreasing part, which is this part of the graph. And then we want to identify between which values of x. Between which values of x? Minus 3 and positive 1. That means it's between minus 3 and positive 1. That is the answer for number 6. If it was increasing, we'll consider the increasing part, that is less than -3 and greater than 1. That is the increasing part. But because we are looking at the decreasing, we'll only consider that one. Okay, grade 12. And then integration. Integration is very easy. Remember, these formulas will be on your formula sheet now. You look into your integration. It is confusing with the derivative, but please do not confuse the two. Derivative is -1 on the exponent. The integration is +1. That is the difference between the two. That one is -1, this one is +1. So before you can integrate, same, you cannot integrate when there are brackets. Remember, in derivative, you can't derive with brackets. So you must remove these brackets here. So we are going to multiply. This will be x cubed plus the 6x squared in bracket and the dx then. Now you relate this to the rules that we are having there. This one is x to the power 3. Can you see is this one? That means it says +1 +1. So that means you'll be saying, oh, this is having relationship with that one. The method is saying take that x and then on the exponent add 1. And the same exponent, you take it to the denominator. I'm just following this, okay? And then plus the 6x squared is this type. Can you see that? It says leave k. K is 6 in this case. And then on x exponent 2, you add 1. You take that exponent to the denominator again. And then this will be plus c because you have integrated. So the final solution here will be equal to x to the power 4 over 4 plus the 3 into 6 is 2 times, then x to the power 3 plus c. Can you see, grade 12, these rules will assist you to integrate. And then we take this one, there's a square root sign. Remember, note that you need to remove this to x to the power half before you integrate. This one, look at the 7 over x is this type. You leave it like that. Plus 4x to the power minus 5, bracket dx. Okay, and then now x to the power half, integration of that one. Remember, this is this type, x to the power half. It will be x half. We add 1 plus 1. That exponent also must also appear in the denominator. Rule number 2, 7 over x is this one. Can you say, it says write it as k in x, the ln of x, k ln x. So our k is 7, and then this x will be a ln x, plus 4x to the power minus 5 is the same as this one. It's a number there to the power number there. Okay, we are applying this rule now. This rule says leave k, so we are leaving 4. And then to the exponent minus 5, we add a 1. And then we take that exponent again, minus 5 plus 1. And then this is now plus c because we have integrated. Now you just simplify this, grade 12. We are having x to the power 3 over 2 over 3 over 2 plus 7 ln x. And then this one will be minus 4 when you simplify this. And then 4 over minus 4 is a negative 1, x to the power negative 4 plus c. That is your integration. Can you see these rules? Your question paper must be here with the information sheet as you are answering this. We check this one now. 3 to the power x. Look at the rules now. Can you see? It's the same as that one because it's a number exponent x. So it says that you take this as it is. Can you see that? As it is. So that means our answer will now be a 3 to the power x over what? The ln of what? Of the number, because it's AA. Our number here is 3. And then now plus 1 over x. Let's target 1 over x is this rule. Can you see that? It says now it's the ln of x. We do exactly that, ln of x. And then you add your plus c because you are integrating. That means all these answers, they come from this rule scripture. You cannot just create something out of nowhere. Okay, now integration. Then we are looking at the area below the curve or above the curve. But if it is below the x-axis, that means this area is a negative area. So the sketch below shaded area show the defined graph. This is a hyperbola graph where x is positive. As you can see, it's only on the positive x values here. determined by showing by calculation the shaded area bounded by the curve and the x-axis between the point x 1,4 and the 3,5 thing. So now, when we are looking at this is the definite integral because it is giving us the definite area because we are giving intervals there. So this will be the area of the shaded area. The shaded area will be equal to the integration starting from the bigger number 3,5 to the lower limit, which is 1,5 of what? Of minus 4 over x. Okay, and then this one will be dx because we need to derive that. And then now we look at the derivative first of minus 4 over x. Remember, you must write this as 3,5, 1,5 here, 1,4, sorry, this is 1,4. And then the integration of minus 4, it will be minus 4. Do you still remember your rules, Rachel? Do you still remember? If it's a minus 4 now, it will be minus 4, and then it's a ln of x. And then in this case, we will not include the plus c because we are looking at the definite integral. Since we know the integration now, the notation here will be the square bracket now with the integrated equation that you'll be busy with. And then the interval for this must be between 3, the upper limit with the lower limit 1 over 4. That is the first thing that we'll be doing, okay? And then now we are now going to substitute these values now. Remember this area, it will be a negative area because it is below the x-axis, right? And then now we substitute minus 4 ln of x. We substitute the upper limit 3,5 for x minus, we now consider the lower limit minus 4 ln of the lower limit 1,4. And then grade 12, you put everything into your calculator straight to the answer. This will give us an area of 3,67 units squared. If it was given in centimeters, it will be square centimeters. If it was given in meters, we will be talking to the square meters. Okay, so that is the integration. Then remember, we talked so much about the finance on our last session. We have simple interest, we have compound interest. Simple, they can say SI, they can say straight line, they can say linear base, they can say hyperchase. Compound interest, they can say reducing population, inflation, exponential. And then now, if you want to use the negative formulas after checking whether it's compound simple, we look at the keyword depreciation, decay, loss, decrease, reduce. You must know that you must use minus formula. The minute it says appreciate, growth, interest, increase in your investment, that means you'll be applying the plus formula there. So for the simple interest, we are using the A, as you can see, N is down there. With the compound, N will be exponential. And then the simple is having a relationship with a straight line graph, and then this one with an exponential graph. This one with a straight line graph. And then effective rate, we are using that formula, grade 12. So look at the key word in order to know, are you taking simple or compound? Look for the keyword to check whether is it the minus or the plus formula. And then also check the compounding annually. In 1 year, we compound only once. I will still be INN. Biannually, half yearly, semi-annually is 2 times. Then I will be affected and N affected by 2. Quarterly, we have 4 quarters in a year. Then it will be I over 4 for N. Week monthly is 12 months in a year. We always compare to a year. And then I will be over 12, N will be 12N. Weekly, we have 52 weeks in a normal year of 365 days. Then it will be 52 weeks. I will be over 52, N. Daily, we have 365. Then I and N will be affected by 365. This one depends on the compoundment, whether it is yearly, monthly, and so forth, grade 12s, right? And then let's take a few activities on financial maths first. And then now the artisan wants to buy a car after seeing advertisement along. The advertisement is saying a new car is 250,000. You pay a deposit of 10%, and then now you will take a loan for the remaining balance. And then you must pay the loan with equal monthly installment over a period of 5 years. And then this will be the interest rate, and then it is compounded monthly. So the first question, determine the loan amount you have to take out of this deal. Remember, you are not borrowing 250,000 because you have 10% in your pocket that you are going to pay as a deposit. That means we need to calculate 10% deposit of 250,000 there. And then how much is 25% of 10% of 250? That is 25,000. So now if you take out 25,000, what is the remaining money that you are taking as a loan? That means your loan will be now how much? The 250, which is the price of the car, minus the 25,000 that you are paying as a deposit. And then this will give us 225,000. So you will be borrowing the 225, not 250. And then number 2, calculate correct one decimal, the effective rate. That is I effective is equal to 1 plus I nominal over M minus 1. From your formula sheet, grade 12 is 1 plus. The I nominal is the rate that is given to you, 6.3%. And then it is compounded monthly. It will be over 12 to the power 12 day, minus 1. Into your calculator, straight to your answer. It will give your answer in decimal 0.06485 and so on. And then you need to multiply this by 100 because the rate must always be in percentage. And this gives us how much now? The 6.5%, because it says to 1 decimal place. All right. And then now another question on finance. An engineer company conducted an audit of number of unskilled workers. This audit was made March 2019. Due to fourth industrial revolution, it is estimated by April 2023, the number of unskilled workers will decrease. The minute you see the word decrease, the formula will be minus. The minute you see compound, it will be of compound interest. By just seeing these two keywords, we know we are using the compound interest with the negative because of decrease and compound. We have identified the formula. And then the rate is 5.43. And then this number is reduced to 60 unskilled. That means now we are given the reduced number 60. Initially, we don't know how many were they. We are only given that they are now at 60. Calculate how many unskilled workers were employed by engineer company when they started during April 2019. Show all your calculations. Grade 12, you have A. AP formula is 1 minus because it's decreasing to the power n. And then now this number have reduced to 60. We want the initial number, which was P. And then 1 minus the rate is 5.43%. And then compounded, this is compounded monthly because it is talking to months there in calculations. And then now we are talking from 2019 to 2023, 2019 to 2023. So this is 5, let's read again. Grade 12, an engineering company conducted an audit of the number of unskilled workers during March 2019 due to 4IR. It is estimated that by 2023, the number of unskilled workers by the company will decrease, go down, okay? And then to 60. Now, the calculation must be during April 2019. 2019, 2020, 21, 22, 23. We are talking 4 years, grade 12. This is not compounded. It's only 4 years there. And then now, because we want P here, we will divide both sides by this bracket here, okay? By 1 minus 5.43% to the power 4, because you want to cancel that bracket. The same applies, 1 minus 5.43% to the power 4 to this side. So it will give you a p-value which is 75.01. Because we are talking to people, unskilled employees, we cannot say 75.01 a number of people. So we'll say P is equal to 75 unskilled workers. Round it off to the nearest person. We cannot say this person is 0.1 person, okay? So that will give us the 75 unskilled persons. So grade 12, thank you very much for today's lesson. This was brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. We wish you all the best on your paper 1 tomorrow, grade 12.